All right, so a couple things before we get going. Let's go to Canvas here. So we'll be doing module 8 this week. So every week at the end of the day, Monday, you should have what due? A module reading, and so a large percent of you did not do the module 7 quiz. So when I copied it over, it didn't keep the due date, right? So it didn't show up on your dashboard, right? So you didn't do it. So every single week you should have that module 7 quiz and that, not 7 quiz, but you should have a module quiz and a module reading. So because that due date kind of wasn't showing up on your dashboard, my mistake is your gain here. If you didn't get that module 7 quiz completed, you have till the end of the day today, right? So if you didn't do it, get it done today. It'll be accepted as not late as long as it's submitted before 11:59 the end of the day tonight, right? So the module reading, everything was fine with that. That module quiz did not have pop up on your dashboard. Once again, shouldn't necessarily just rely on that. You should always have a module quiz and a module reading due at the end of the day Monday every single week, with the exception of exams, okay? Any questions on that? If you ever have issues in class with the module in-class quizzes, what should you do as soon as class is over? Take a wild guess. Do we have Pulse this morning? If it doesn't work for you in class, what do you think you should do after class? Come up and talk to me, right? Right after class, okay? So if I'm getting emails and you're submitting this 40 minutes late, what do I think you probably did? Probably got the code from a friend and submitted it late, right? So if you're having issues with these in-class quizzes, always let me know immediately after class, okay? I know I've said this before, right? We shouldn't have any kind of issues in class. I always have been double checking about the Wi-Fi, things like that. So kind of moving forward, you know, if I'm a little short in my emails, if you send that to me, when I say that, it's because I know I'm saying that in class. If you're in class, you know you should be coming up and talk to me immediately following class, okay? All right, so that should kind of take care of all the housekeeping stuff. The only other thing I'll mention is that Canvas discussion. My GAs are starting the grading today, so you'll start to see grades probably pop up for that. They have to go through each individuals and kind of assign the score. So you'll see those kind of pop up throughout the next couple days. You might have seen them yesterday. I told them to start yesterday if they had time, but some of them aren't starting till today, okay? Other than that, I think we should be good to go to jump into this week's material, unless there's any other questions for me. Okay? All right. So we'll be looking at module 8 this week, right? So I've said before, you know, and people have been coming to review their exams. This will probably hopefully pay off this week, because what we're going to be doing today looks really similar in a lot of ways to what we talked about in module 2. So I'll try to make those connections. If it helps you, then hold on to that. If not, you can think about it as a completely separate issue. But I think a lot of what we talked about in module 2 will really help us out this week, okay? So what we're going to be doing is thinking about everything just from a consumer standpoint this week. So it kind of gets easier. Last couple of weeks, we had consumers, producers, the government, lots of people, right? Here, we're just thinking about consumers. So if I'm thinking about, I've got the decision to make to buy a good, we said usually people would make a decision based off of what? The marginal benefit relative to the marginal cost. So we're now going to think about not just one good, but I can buy multiple goods. So how do I decide whether or not I buy good X or good Y? So we'll kind of keep it simple with just 2 goods to start out. And we'll think about this, what we call a budget line, right? So I have these 2 goods that I want to buy. How do I know which one, you know, how much of each good I should be buying? It's going to be some function of the prices of those 2 goods. I think intuitively that makes sense. But then also, how much money do I have? Okay? So I've got this set up here where initially we have $40 as our income. M just always represents income in economics. I'll kind of write this out so we can make that connection. And then I've got the prices of these 2 goods as well. So if I'm thinking about graphing this, right, I have all these different combinations of good X and good Y that I can afford to buy, right? So if I think about, just for right now, accepting this fact that my income constraint, or if I'm spending all of my money, what are the different combinations of these two goods I can afford to buy? Well, it's going to be the sum of how much I'm spending on good X and how much I'm spending on good Y. How much am I spending on good X? However many units I'm buying, times the price of that good. Plus, what's the total amount of money I'm spending on good Y? Total number of units I'm buying, times the price of that good. So an easier way maybe initially to think about that budget constraint is, if I'm only buying good X, how much total can I afford to buy? Well, if I'm only buying good X, what's the quantity of good Y? 0. So I'm left with, how much of good X can I afford to buy? If I just rearrange this a little bit, divide both sides by the price of good X here, I get, when I'm only buying good X, the amount that I can afford to buy is how much money I have in my pocket, my income, divided by the price of that good. If I have $100, something costs 10, I can buy 10 of them, right? So for us, we had $40 was our income. The price of good X, I think we were told, was 2. So I'm thinking about, if I can only buy good X, the quantity I can buy would be 20, right? So I can find these intercept values because they just represent, if I'm only buying that good, how much could I afford to buy? Right? So I just need to know the income I've got and the price of that good. If instead I wanted to know, well, what if I'm only buying good Y? Well, what's the total amount of good Y I could buy? The number of units of good Y that I'm buying times the price of that good. So here, if I know that income is 40, price of good Y I was told was 5. If I just rearrange this a little bit, the quantity of good Y I can afford to buy would be M over the price of that good, or in our example, right, 8. Okay. So how do I find those extreme points? It's simply take my income and divide it by the price of that good. Okay. I don't think that's anything too wild, right? If I was just only buying something, how much can I afford to buy? However many dollars I have, divided by how much each unit's going to cost me. Okay. Everybody with me up to that point? Does that make sense? Now, if I think about starting out where I'm only buying good Y, as I start to buy some of good X, what am I going to have to do? If I was spending all of my income here, as I buy more of good X, I'm going to have to do what? Buy less of good Y. So there's this trade-off that as I buy more of one good, I have to buy less of the other. I only have a certain amount of money, right? So this is going to be our budget line. This budget line is going to represent different combinations of these two goods that I can afford to buy. Okay? So before I go a little bit further, I want to jump the gun a little bit here. But what does this start to look similar to? I've got quantity of X and Y. This looks like my production possibilities curve, right? All the way back in module 2. So if I think about this as being my production, what was every point on the production possibilities curve? We said it was production efficient. Well, if I'm only thinking about consumers here, every point here, I'm using all of my resources of income. These points we could think about as being consumption efficient. Okay? And then any point below must mean I'm doing what? Well, every point here, I'm spending all of my income. So any point below means I must be not spending all of my income, or I'm being inefficient with my resource, right? If I was looking at points up here, what would be true about all these? Usually we said with the PPC it was unattainable. Now, how would I maybe phrase this for consumers? Well, if I'm spending all of my income here, what's true about that point? It would be unaffordable, right? So it's really the same thing we were doing with the PPC, just in the context of a consumer. Every point on the curve, we're spending all of our income using all of our resources. We're being consumption efficient. Any point below that, we're not using all of our resources. We're being consumption inefficient. Any point above that, it's unattainable, or how would we say for a consumer, it would be unaffordable, right? So it's really the same thing we were doing with that production possibilities curve, just for consumers. Okay. Now, what we also said with the PPC, and this is where it's different ways of thinking about this. So if I've got the quantity of good X and the quantity of good Y, right? If I was using quantities, how could I figure out the slope? It would simply be the change in what? The change in slope is always the change in whatever's on your y-axis over the change in your x-axis. Here I've got quantities, so the change in the quantity of good X, which between these 2 points would be what? -8. The change in the quantity of good X, sorry, I might have said X instead. What's the change in the quantity of good Y? -8. Divided by the change in the quantity of good X, that was 20. So here I'd have, this would be what? -0.4, if I'm doing math in my head correct. Okay. So we can still use quantities to find slopes. What should this tell me? The cost of my, what did the slope of the PPC tell you? The cost of your x-axis good. So this is now the cost of my consumer of the x-axis good. Nothing's changed, right? It's just we're looking at consumers instead of producers. Okay. Now, if I wanted to solve this model, right, and I'm thinking about here I had the original budget constraint equation. I can use quantities, but remember, what was behind these quantities? It was income over the price of each one of these goods. So there's different ways of thinking about finding my slope. If 8 is simply taking income over the price of good Y in our example, what would my change in Y be? Just -m over the price of good Y. What's my change in X? 20 was simply representing m over the price of good X. If I do a little bit of algebra here, which I'm going to do some algebra here today, I'm not going to like line by line do it. It should be hopefully somewhat simple. If I have the same thing in my numerator, that cancels. 1 over something divided by 1 over that, they would just get flipped. This is the same as saying the price of good X over the price of good Y is going to be my slope, right? Now I could also think about here, if I rearrange this equation, what's the slope of a line? Y is equal to mx plus b, right? So what is on my y-axis? The quantity of y. So I'm just going to rearrange this equation where I solve for the quantity of good y. So I subtract this from both sides. I'm left with what? Price of y, quantity of y is equal to m over price of x, quantity of x. I then divide both sides by the price of y. And what I would have is an equation that looks like this, right? I'm just rearranging this equation. Sure enough, what do I end up with? My budget line equation starts out where? At that intercept where I'm taking income, dividing it by the price of good Y. When I'm only buying good Y, X would be 0. This is where I start. That's my intercept. That's my B, right? What is my slope? M. Well, as I buy more of good X, how much of good Y do I have to give up? It's always going to be the relative price of good X to the price of good Y. If I do that in this case, what would the price of X over price of Y be? I think the values we were given were 2 and 5. Sure enough, I get the same value as if I use the quantities. Okay? So we can use quantities to solve for that slope, but we also always know that slope will be the relative prices. Now, this is where it's a little bit counterintuitive, where the slope is not going to be Y over X when we use prices. It ends up being the price of good X over the price of good Y, right? And the reason is just, I mean, we walked through the algebra, it's just the math, right? It's just algebraically what that slope of the equation would always be, okay? So I'm showing you multiple ways of getting at it. We don't have to do every single one every time, but there's just different ways of thinking about why our slope for that budget equation is going to be that relative price of good X to the price of good Y. Okay? Questions over anything here? I know I went through that kind of quick, but a lot of it is just kind of the algebra we're rearranging. We kind of just care about what that end result is going to be. Okay? Now's the time to ask questions. Don't be a free rider, right? So we've got kind of, I plug those prices in to my budget constraint. I could kind of rearrange that. We kind of already looked at that up on the dot cam. Now, I already mentioned all these things, trying to kind of just compare this to something we already know. We said that production possibilities curve was always going to be a slope that was negative. Same thing for our consumption or our budget equation, right? Our consumption line or our budget line or however we want to kind of reference it, our budget constraint. It's going to represent that if I want to buy more of good X, I have to give up of buying some of good Y if I'm using all of my income. Right? So we know the slope is always going to be negative. I'm also going to always keep it linear. Doesn't have to be, right? Now, in most examples we think about, the price of a good is usually fixed. So those relative prices should always be the same, so it will be linear. If we wanted to complicate this and think about we had the choice not between two goods, but three, then we would start to see, just like the production possibilities curve, it would start to like bow out. I won't push you guys that far. We're only going to look at the choice of two goods, so it'll always be linear. Okay? And then we talked about any point on the line I can afford, every point above the line unaffordable, any point below I can afford it, but I'm not using all of my income, or I'm being consumption inefficient. Okay? So these should, like I said, hopefully, it's sounding familiar from what we talked about in module 2. Okay? It's just all in the context of consumers now. Right? Any questions on that? Okay? So let's go use some different values. We'll maybe think about some different types of questions we could see, or eventually we'll talk about some changes that we could see occur in these models. So let's say I'm trying to reinvent my image and I'm only buying flannel shirts and PBR, right? So I've got $200 total of income to spend. I'm either going to buy cans of PBR or flannel shirts. I know the price of flannel shirts is $20, can of PBR is $5. I can start to think about, what is my budget constraint going to look like, okay? So I can start to build this out. And I think, did I tell you here? Sorry, if we go back to the slides, the next bullet point, I told you what good to put on the x-axis, which was flannel shirts, just so that we kind of work along the same with the slides, okay? So what would my budget constraint look like? Well, I've got my income is going to be equal to the price times the quantity of my X good, plus the price times the quantity of my Y good, okay? Now, I know some of these values. I know here this is 200. I know this is 20, and I was told this is 5, okay? So how am I going to find those extreme points? If I'm only buying good X, how much total can I afford to buy? I simply take my... So if you go into a store and you want to buy something, it costs you $10. How many could you buy if you had $200 in your pocket? 20. What did you do there in your head? All you did was take the amount of income you have and you divided it by the price of whatever good you were thinking about. That's the only good I'm buying. So here, if I'm only buying flannel shirts, how much total can I afford to buy? This would be what? 200 over 20 or 10, right? If I'm only buying PBR, how many total can I afford to buy? Well, that would be my income divided by the price of that good, right? So I would get here what? 40? So I would always start, you can think about these extreme points, it's just take however much money I've got and divide it by the price of that good. Now the points in the middle get trickier, right? So here I'm thinking about, right? What would the slope of my budget constraint be here, or my income kind of line? Well, I said before, it's going to be what? My relative prices, right? But it's the price of what? Good X over the price of good Y. So here we've got flannel shirts over cans of PBR. So I've got what? Flannel shirts were 20, PBR is 4. So I get 4 here, but the slope should always be negative, right? Representing that when I want one more of the x-axis good, remember, just like the PPC, this tells me the cost of my x-axis good. So to get one more flannel shirt, what does that 4 really represent? I'm having to give up 4 of my y-axis good, okay? And if we just think about the relative prices, that makes sense for us. If a flannel shirt costs $20, can of PBR is 5. If I want to buy one more flannel shirt, I need 20 bucks. So how many fewer cans of PBR do I have to buy? Well, if each one is 5, 4 times 5 would get me that $20. All I'm doing is taking the relative price of good X over the price of good Y. Right? So if a flannel shirt cost me $30, what would the new cost be? Well, if I want one more flannel shirt, how many cans am I now going to have to give up? If you need $30, something costs you 5. How many do you have to give up to get that $30? 6, all right? Your new slope would be 6. It's that relative price, right? So it's because you need that amount of money to buy one more of that x-axis good. That's why it will be your relative prices, okay? So I can start to think about what are different points I could afford to buy, right? So I think we've got everything on here that we want. I think the next slide, we start to think about, well, which of these 3 values, and I told you where the points are. I'm going to build this out for us in a second. But I found those 2 extreme points. I figured out kind of what my slope was. Now, one thing that's interesting to point out here, when I had those quantities, the relative price should always be my slope. We've used relative prices to find that slope of -4. But notice if I find those 2 extreme points, if I use the quantities, right, the change in the quantity of y over the quantity of x, because that's what's on my x and y axis, what would I find the slope to be? Well, if I'm going from 40, right, 0, 40 to 10, 0, the change in y was -40. The change in x was 10. 40 over 10 would also give me that same value of -4, or the same as my relative prices. Okay? So I can use the quantities, or I can use that relative price. Okay? Now, how do I figure out if these points are on my curve? Right? Well, the first point was 225. Okay? So if I think about, I can do this in 2 ways. Right? If I was here and I wanted 2 flannel shirts, how many cans of PBR is each shirt costing me? 4. So what's my total cost? 2 times 4, right? Each one. So my total cost would be 8. So if I wanted 2 flannel shirts, how many cans of PBR can I now afford? Well, I had to give up buying 8, so I'd be at 232. So that point that I'm given in the slides of 225 would actually be down here, or I would say that I'm doing what at that point? Being inefficient. I'm not spending all of my income. Okay? Now, what about the point of 8 and 8? If I want 8 flannel shirts, what's my total cost? Well, if each one is costing me 4 of the y-axis good, my total cost would be 32. So 40 minus 32, that point where I'm at on my curve, should be at 8 and 8. Sure enough, that point B, I think if I'm labeling these to line up with the slides, that point of B is on my curve. That represents a point where I'm spending all of my income. Now, another way of thinking about checking these points is if I had my budget equation, right? So if I just kind of plug in what I have here, so my income was 200, price of a flannel shirt was 20, price of PBR was 5. can I afford, or how much money am I spending if both these values are 8? Well, I just do the math here. 8 times 5 plus 8 times 20, sure enough, I'm spending $200 here. Well, what about that first point, which was 2 and I was told 25, right? Well, if I plug those values in, 2 and 25, this would be what, 40 plus 125. I'm only spending $165 there. So I'm not spending all of my income. Now I've got a third point, which was 5 and 30. So if I was buying 5 flannel shirts, once again, 2 ways of thinking about this. I could plug them in here, so I could go 5 and 30. If I do the math here, I've got what? 150 plus 100, so I'd be spending 250. Where should this point be? Somewhere above my budget line. Or I could think about what should the total cost be if I bought 5 flannel shirts. 5 times 4 would be 20. So 40 minus 20, the point that would be at on my curve would be at a point of 5 and 20. So that point of 525 would be up here, or sure enough, is a point where I'm spending more money than I have. Right? So kind of 2 different ways of thinking about checking these points. If this to me makes more sense. Like I can plug things in this equation and figure it out, but I like to think about things graphically, so I prefer to do this method. But if this works for you, anytime you plug your quantities in, if it's equal to 200, you know that you're on the budget line, right? You're spending all of your money. If you're at less than 200, you know that you're at an inefficient point. You're not spending all of your income. And if you're at a point that's greater than 200 here, you would have a point where you can't afford it. Right? It should be a point above, right? So kind of 2 different ways of kind of figuring out whether or not these points are on your budget line or not. Okay. Any questions over anything here? Because we're just going to keep building on this. Plugged into what? This? So we had 3 possible points we were trying to figure out if they were on our budget constraint or not, right? So one way to check that is just plug in those different combinations of quantities. So I tried to color code them, right? 225, right? I checked to see how much money I'm spending there. It was less than my income of 200, so it was below. The second point was 8 and 8. I found, okay, I'm spending all of my money there. The third point, 5 and 30, I plugged those in. I found I was spending more money than I had. So all I'm doing there is kind of checking hypothetical points. Now, that doesn't really work if I said, let's say I asked you the question, you're buying 10 flannel shirts, how many cans of PBR can you afford? You can still plug them into the equation and like do some algebra. But right, it's just going to be a slightly different method. You'll have that budget line, you'd have your prices, you'd have your income. You only know one quantity. You have to figure out what would the other quantity be. Right? And that's where I think maybe thinking about it graphically and like moving, like doing it the other way so that you have a visual might be a little bit more helpful. Right? But both ways you can do it. Is that what you're asking? Yeah. Yeah, so if we think about, is it affordable? Yes, right? But I'm not spending all of my income. Yep. Only those points that are on my curve are affordable, but I'm using all of my resources. Yeah, so if I just want to know what's affordable, I could think about A and B would be affordable. What point, though, would also be inefficient? Point A. Yep. Really, and so everything I shaded here, that whole blue area, would all be points that are affordable. Okay? Any other questions here before we keep moving? Okay? So we've got this budget constraint, and I've tried to like make the connection between it and the production possibilities curve because it's a lot of the same reoccurring kind of themes and concepts. So let's start to think about, what if I have income and price changes? So probably the easiest thing to think about is if I have an income change, right? So if I have an income change, if I'm only buying X, can I now buy more or less than I was before? So, sorry, I have to tell you what direction. If I have more income, right, can I buy more or less what I had before? If I'm only buying good Y and I have more income, can I afford to buy more or less than I was before? So both those intercepts are going to increase. Now, if my income went up, but prices didn't change, what should be true about my slope? The slope should always be my relative prices. Does that factor in income at all? So what should be the slope of my new budget constraint or my budget line? Exactly the same. So if I have increases in income, I'm going to get this nice kind of parallel shift in my budget constraint. Now, I always know the slope will be the relative prices, so I don't really need to recalculate it, but I could prove myself. So in this example, I said, let's say income went from $200 to $300. How many flannel shirts can I now afford to buy? I would take that income of 300, divide it by the price of 20. I can now afford to buy, instead of 10, 15. What if I'm only buying PBR? Take the price or income of 300 divided by the price of 5. I can now afford to buy 60. Notice if I use the quantities, before it was 40 over 10, gave me that slope of -4, right? Which was the same as my relative prices of 20 over 5. Notice my new quantities, 60 over 15, if I use those, what's my new slope? Still -4, right? Because my relative prices haven't changed. So if I use the quantities after the income change, I can still prove to myself my slope hasn't changed at all. My quantities are both higher, right? So all I've done is see a nice parallel shift in that budget line, okay? Now, what if I saw an income decrease? What would I see there? My budget line would shift closer to 0. So hopefully this starts to look similar. If this black line is kind of my starting point, if I see an increase in income, that means I can buy more of both goods if I'm only buying those. What does an increase look like? It's a movement away from that 0 point. Increases in our budget line start to look like increases in what? What else is downward sloping? Demand, right? And we're talking about consumers, so makes sense, right? Now, if I saw income decreases, that starts to look like a decrease in demand. So here you might start to think, well, yeah, this is the same thing we talked about for what types of goods. More income, I buy more of them. That's going to look like a normal good. Next class, we're actually going to talk, and I'll mention at the end, we're going to talk about, this is always the way. It doesn't matter if it's a normal or inferior good. We would always kind of get this shift in income that looks like this. But depending on what the type of good is, we can see that the end result will be possibly from this increase in income, I buy less of that good. We need a little bit more pieces of the puzzle before we look at why inferior goods are what they are, but we will touch on that on Thursday. So for us right now, it doesn't matter if they're normal or inferior. Income will always increase your budget constraint. Income increases will always increase your budget constraint. Income decreases will always decrease your budget constraint. Doesn't matter what type of good, normal, or inferior you have. We'll kind of look more into that on Thursday, okay? So for us, higher income, what's true about all the points here? Before, these points would have been what? Unaffordable. After I have more income, all these points are now affordable and, in fact, inefficient. When I have less income, all these points used to be affordable and are now unaffordable, right? So it doesn't matter if they're normal or inferior goods. We see that shift in the budget constraint works the exact same way, okay? Any questions on this idea? Yeah. Yep, as long as income changes. So remember why? Well, I shouldn't say remember, but because we just did it today. Oh, I should have just wrote this out, I guess. Here it is. Remember when I showed you that other way of thinking about what happened? Income always canceled. So income won't ever change the slope of your budget constraint. that slope will always be the same when we have income changes. Yep. Any other questions here? Okay. All right. So what if instead, and I want to make sure this matches up with this slide. So my markers are bleeding. All right. So let's say we go back, we have our original example. And I think it was like what, 40 and 10 were our points. So let's say I've got the price of flannel shirts goes down to $10 instead of 20. So there's a couple different ways we can think about what's going to happen. I think maybe the easiest way is, okay, if I'm only buying cans of PBR, we said we can find that by taking the income, dividing it by the price of that good. What's going to happen to that point? Did income change? Did the price of PBR change? So if I only buy PBR, the fact that flannel shirts are cheaper does what? Doesn't do a damn thing, right? I can still buy the exact same amount. Now, if I'm buying flannel shirts, well, my income didn't change, but because the price is lower, if I'm only buying flannel shirts, I can now afford to buy, well, here they went from 20 to 10. I could now afford to buy twice as many as I was before. So what's going to happen to my budget line when I see a decrease in the price of a good? It's going to kick it out, right? Now we can start to think about what this looks similar to. Now, usually we talked about these in the economy-wide production possibilities curve model, but what's something that only shifted one side? Technology, right? What did technology do? It decreased the price of that good. Notice, when I see a decrease in the price of this good, what happens? I can now afford to buy more of it. And what's happening to my slope? So before, it was what? -4. What's my new slope going to be? Well, if I use the quantities, my new slope would be what? -2, 40 over 20. But also remember, what is the slope? It's the price of good X over the price of good Y. So the price of my flannel shirts over the price of PBR. When the price of my flannel shirt went down, what happened to that cost, or what happened to that slope? It also went down, right? My curve was getting flatter. So when the price of a good goes down, the slope still tells us the cost of that x-axis good. It's just now it's the relative cost of that good compared to the y-axis good. Well, the y-axis good is the same amount of money. The x-axis good is cheaper. So now the relative cost of my x-axis good should be lower, or a flatter slope. Flatter slope. Curve slope, I just combine those two words, right? So we've got a flatter kind of slope here, right? Which represents the cost of this good went down. It was driven by the cost was going down. The price was now lower, okay? Any questions on that idea? So every point in this range at the old prices was what? Affordable, right? In fact, they weren't affordable. What were these points before the price change? Unaffordable, right? Only the points on my curve were affordable. So all these points that were unaffordable, when the price of that x-axis good went down, now all these points are affordable, right? So this kind of intuitively makes sense. When the price of a good goes down, now any consumption, what we call bundle, any combination of these two goods that I was buying before, I can now buy the same amount of Y, but more of the x-axis good, right? So the same thing would work if I saw the price of Y change, right? So let's say I'll do the reverse here so we get kind of two different views. Let's say I've got flannel shirts and I've got PBR and I've got, here's my old budget constraint. And let's say the price of PBR goes up. two different ways of thinking about it. First of all, if I just think about the slope, it's the price of the X good over the price of the Y good. So price of flannel shirts over the price of PBR. If this goes up, what's happening to my fraction? My fraction's actually going down. So my new slope should be flatter, right? The cost of my Y-axis good is going up. It's actually going to cause the relative price of the X-axis good to go down. Now, maybe an easier way to think about this, I would probably think about it this way first. If the price of PBR is going up and I'm only buying PBR, we said we found this point by taking income, dividing it by the price of that good. So if this good is more expensive, can I afford to buy more or less than I was before? Less, right? Because that good is more expensive now. I have the same income. If I'm only buying flannel shirts, how many can I afford to buy? Well, it didn't have a change in its price. Income is the same. I would have something like this, which now has a flatter slope, right? So if the price of the X good goes down, I can get a flatter slope because its relative price would now be lower. But if I have a change in the price of the Y good and it goes up, that also causes my relative price for good X to go down as well, right? So you can kind of think about the reason why is because now anytime I'm buying a unit of good X, right, its old price is essentially relative to the other price is now going to be smaller. So if you thought about before, like, let's say the prices were the same, 20 and 20, right? Well, now if the price of good Y goes up to 30, the relative price of good X is only 20 over 30. So instead of 1, it's now something less than 1, right? So kind of this idea of relative price is a little bit less intuitive and tricky to think about, which once again, a suggestion I always get, because it's somewhat counterintuitive, what's probably always good to do? Draw the graph out, all right? Then we can kind of see, oh yeah, when the price of the Y good goes up, I can afford to buy less of it. Sure enough, that made my slope flatter. So that relative price of good X is now going to be lower, right? Or the slope is lower, okay? So when the price of goods go up, what was true about all these points before? They were affordable. Now all these points are unaffordable. Or said differently, if I keep buying the same amount of good Y, I can now afford to buy less of good X with the same amount of income, okay? Any questions over anything here? Okay. All right. No, this is getting tricky, right? So I can kind of put different values to this. I think here I had on the slides, I only had a decrease in the price of flannel shirts. I wanted to draw out what happens if we had an increase in the price of one of those goods as well, just to kind of think about we could do either one. And I'm not going to go through every single possible combination sometimes in class. Like technically, what could I also do? I did an increase in the price of good Y and a decrease in the price of X individually. I could also do a decrease in the price of Y, increase in the price of X. Everything would just kind of work exact opposite, right? So you should be able to draw out each one of these possible changes in price, okay? Now, the result is usually intuitive. If prices go up, there was points before I could afford that I no longer can. Prices go down, there were points that I used to be able to not afford that I now can afford, right? So let's think about one other thing I didn't really mention, and this will kind of play out here in a second. But before we get there, I want to show you this and start to think about if the black line is like our starting point, how could I get point B? Point B would be a change in what? Well, the slope has changed, so automatically I should be thinking about it was a change in price, right? The relative price of the two goods has changed. If I see that I can now buy more of good X, but the same amount of good Y, that means that I must have been a change in the price of good X. If I can buy more, that must mean that the price of X went down, right? So B would represent a decrease in the price of good X. What about C? Well, I can buy the same amount of good X, but the slope has changed, so I know I must have had a change in the price of some good. If I can buy more of good Y, that means that it must have been a change in the price of good Y. If I can buy more of it, it means that the price of Y must have went down. Now, A, I've got the same slope. So it should look like what we have talked about. If I can now buy more of both goods, right, it should be a what change in income? An income increase. What if I told you income didn't change? Yeah, what would allow me to buy, if income stays the same, what would allow me to be able to buy more of good X with the same amount of money, but also more of Y with the same amount of money? If both of the goods saw a price decrease, and if that price decrease was the same, right, proportional change. Now, we won't always see this happen, but it can. What would this look similar to? Maybe we'll do the opposite, right? What'd you say? So be careful, right? Maybe these price changes happened independently. Let's think about the reverse. If I had an income decrease, what would happen with my black line? It would shift to the left. That could also be caused by if the price of both goods went up. If the price of goods go up, I can now afford to buy less of them. What does that sound similar to? A word that we use, you might hear in the news, starts with an I. Inflation, right? So if prices go down, it's the same thing if it's a proportional change. It looks like it's an income increase. That would actually look like deflation, right? So income changes could also be caused if the price of both goods change, right? Now, the reason why is because when we think about this change in income, and this will kind of lead us into next class, right? So when I was thinking about these 2 points, and this was income over the price of both goods, if income stays the same, but both goods have a price decrease, that's the same thing as an increase in income. Why? Because even though I have the same amount of money in my pocket, what can I now buy? More or less than before? More. So we said that would actually be like a real income change. So when we have changes in prices, even though income stays the same, my real income, what my income can buy, actually goes up, right? When prices are lower, the same $100 in my pocket, I can now get more goods, right? So this shift outward, yes, having more income would cause that shift, but also having the same income with lower prices overall could also cause that same shift upward, okay? So I just want to kind of make that point because we'll touch on this a little bit next class, where it doesn't have to be an income change that causes these parallel shifts. It could be a change in both prices if they were proportional changes, okay? All right. Any questions on that before we keep moving here? All right, so maybe went a little bit slower here. I'll kind of publish this quiz. Oh, we should be good. Let's do. Nope. Make sure we have plenty of time here. Okay, so this should pop up on the home page or under the quizzes tab. We should get through this relatively quick. So in-class quiz, I believe today's number is 30.20. So I think you need both the second, so you can't put 30.2. I don't think that'll work. So it needs to be 30.20. Is it asking you for a code to get into it? It should. Okay. All right. So this is kind of what we'll be doing moving forward, is kind of having these codes to unlock the quiz in class. So 30.20 would be today's. Okay. Everybody getting in okay? Yes, no, thumbs up. Okay. Thumbs down. Is it Wi-Fi issues or is the code not working? Okay. Well, hopefully we'll kind of give it some time as we work through these. It should kind of catch up with us. All right. So if I've got an example like this, right, where I'm giving you two goods, okay, I tell you the price of, or I give you income, right? So if I know income and I don't know the prices of these two goods, what am I going to look for in this graph to help me solve for the price of, I think, T here? Quantity, right? Because the quantity of T I can afford to buy if I'm only buying T would be what? The total amount of income I have divided by the price of T, right? So if I've got my income is $200, I know that if I'm only buying T, I can afford to buy how much? $50. We've got to be able to read a graph, right? I look up that T, right? Sorry, maybe it's because I have it scrolled up. There we go. Coffee is on my x-axis, T is on my y-axis, so 50. So I know that my income over the price of T should be equal to 50. So we said before, well, how do I find these intercept values? I would take my income, divide it by the price of that good, right? Well, here I've got $200 of income. I know the quantity of T I could afford to buy was 50. It's just a little bit of algebra to solve for that thing I don't know, right? So I kind of rearrange this so that I've got the price of T would be what? Income over the quantity. Plug those values in, and I get the price should be what? 4. Okay. Everybody with me on that? Okay. Now, the second question is a little bit trickier, and there's 2 ways to solve it. So I changed the numbers a little bit from the first one. So we'll think about, I'll show you what I think is the easiest way first. So I've got coffee and tea, and I think now the extreme points are 40 and 100. Okay. And I told you, assume the price of tea is equal to $2. I don't tell you income. Now, it's not going to be as easy as before. Now, this is how I would solve it, but I'll show you a second way after the fact. What is the slope of this line going to represent? My relative prices. It's going to be the price of good X over the price of good Y, or in our case, the price of coffee over the price of tea. Well, what we're looking for is that price of coffee. Okay? I know the price of tea is $2. How can I also find this slope? Using the quantities. I've got the 2 extreme values. So if I find the slope, right, as the change in the quantity of good Y over the change in the quantity of good X, this would be what? T is on my Y-axis, coffee is on my X-axis. I'm going from 40 to 0, so negative 40. I'm going from 0 to 100, so my slope should be negative 0.4. So I know my relative prices should be equal to that slope. Well, if I know the price of tea is $2, I was told that in the problem, a little bit of algebra, the price of coffee must be equal to what? 2 times, and this is where if I've got the negative sign, that's the slope is always negative. So the price of the other good won't be negative. What? 0.8? It'll simply be 0.8. Okay? So knowing that the slope represents the relative prices, if I can find the slope using quantities, now as soon as I know one of the goods prices, I know automatically would then know the other ones. Okay? All right? So if I told you the price of coffee in this example was 0.8, you could then actually back out that the price of tea must have been $2. I could give you either price and you could tell me the other one. Okay? Any questions on this idea before I show you the other method of solving this? Yeah. Do you have a question? So I started out, how do I find the slope of any curve? If I know the X and Y values, it's the change in Y over the change in X. This is like any graph, right? So I found that first by just taking that change in Y over the change in X, 40 over 100. So that's 0.4 is my slope, right? I know my slope also in these models represents my relative prices. I was told in the problem what the price of t is. So if I know the slope, I know the price of t, it's then just a little bit of algebra to solve for that one thing I don't know. Yep. Any other questions on that one? Okay. Now, how could I also have done this? Let's say I didn't want to use the slope. If I know the price of t is $2, how could I find income? Well, my income over the price of t should give me the total amount of t I could afford to buy if that's all I was buying. So if my income, or sorry, the price of tea was $2, I know I can afford to buy 40. It's a little bit of algebra to solve that my income must have been what? 80. I'm just doing the algebra here, multiply both sides by 2. Income must have been 80. Well, now that I know income, how can I use that to help me find the price of coffee? Well, I know this point was income over the price of what? Coffee, because that's the good I'm looking at. So if I now know this is 200, 100 is equal to 200 over the price of coffee. It's just a little bit of algebra to kind of then solve for the price of coffee must be what? Oh, wait, what did I do wrong here? It's not 200. That was the first question, wasn't it? Sorry. In this one, the income is 80, right? So if I then do a little bit of algebra to solve for the price of coffee, the price of coffee would be what? 80 over 100, or sure enough, give me that exact same value of 0.8. So there really are, and I tried to color code them, 2 different ways you could have solved this one. I think using the relative prices is probably easier. And for things that we're going to do next class, understanding that that slope is the relative prices is going to be something that we keep using. So I would maybe try to rely on that method a little bit more. But technically, I could have used either one here. Okay. Any other questions on this one before we keep moving here? Okay. So we've got 2 of these down, all right? So we had what? The price of coffee, and the first one was 4, or sorry, price of tea was 4. Price of coffee here was 0.8. Which of the following would be true? So I kind of have a very similar picture I already showed you. The black line is like our starting point. We said, what could A represent? An increase in income or a what? A proportional decrease in the price of both goods. So A would actually be a price not increase in both goods, but a price decrease. All right? If I saw an increase in the price of good X, what would actually happen to my original black budget constraint? If I'm only buying X, I can now afford to buy less. I would actually have a curve that went like that. So line B actually doesn't tell me an increase in the price of good X. If I can buy more of good X, that must have been from a price decrease. All right, so that one isn't true either. C, how do I get, if I'm buying the same amount of good X, but I can buy more of good Y, it must have been that the price of Y went down, or line C would represent a price decrease in good Y. That one's true, so hopefully D's not true, right? Because we're looking for which one is true here. A would represent a decrease in income. We said A would actually be a increase in income or a proportional decrease in the price of both goods. Yep. So sometimes these questions are things, very similar to what we've already talked through. I just want to kind of have you, be able to look at them, kind of go back and review them after the fact. Okay. Any questions over any of those, or you want to see something or had a question over how I worked through something, even though it was the first question, second question? Hearing a lot of murmurings. We don't have any questions? Okay. All right, so I think I had that set to be what, 12:15? So anybody still having Wi-Fi issues? Speak now, or if I get an email from you later, I'm going to tell you you're lying to me, right? Okay, so the Wi-Fi is good. It's not due for another 5 minutes. Make sure you're clicking that submit button. If I get an email about I forgot to click submit, once again, I'm telling you to do it right now, okay? So to end class out here, we're going to kind of touch on a concept that we'll use next class and hopefully connect this to some things that we've already talked about, right? So basic definitions. Here, we're going to be thinking about, I can buy these two goods. In practice, I can buy a lot more than two goods, right? So there's going to be all these different consumption bundles we can buy. That's just the different combinations of goods that we can buy. Now, typically, I'll keep this at two just to simplify it, right? But, you know, it could be like I'm buying 2 TVs, 1 car, 100 gallons of milk, etc. How do you choose? Why do you choose to buy a different combination of goods than maybe someone else? Even though the prices are the same, and even if maybe you have the exact same income, because you might like certain goods more than somebody else. How much you like something or the happiness it brings you or the benefit you get from consuming something, we're going to call utility. It's just an econ fancy word of essentially talking about how much happiness something brings you, right? So this idea of utility is when I buy something, what's the overall benefit to me or the overall happiness that I get from consuming that good? Okay, so our utility function, right? We won't really dive too deep into these in this class, but it's going to tell you if I buy a certain amount of good X, here's the total utility that it would give me, okay, or the total happiness. Okay? So with this idea of utility in mind, right, we have kind of a weird thing going on. People make decisions based off of what? As long as the marginal benefit is greater than or equal to the, so we make decisions on the margin, not based off of totals. So this is where we can get some weird things happening. So total utility is the total utility that's derived from all of your consumption of one good, okay? So however much you're buying, you know, gallons of milk, what's that total level of happiness all of those gallons of milk bring you, in my weird example, right? Marginal utility is going to be like anything else we calculate. It's the change in that thing coming from a change in how much you're either producing or you're consuming. Well, I said this whole chapter is going to be consumers. So now instead of the quantity you're producing, like when we calculated marginal costs, it was the change in total cost divided by a change in the number of units. Now we're looking at marginal utility. It's a change in the total utility divided by a change in the number of units you're consuming as opposed to producing. So very similar to marginal cost, it's just now we're thinking about it's the additional benefits, right? Or the marginal benefit. We're looking at consumers, okay? So if I'm thinking about every time I buy something in general, and I'll show you an example in a second where this isn't true because the book mentions it. Marginal utility, if you have more of something, generally the additional utility get will always, the additional utility you get will always be greater than 0. Even if it's small, having more of something is generally going to give you some slight amount of additional happiness or benefit, okay? So if we're thinking about a table like this, right, how would I calculate marginal utility? So I think my slides, I have my animation set wrong, but it's okay. It's good for you to go back and then be able to kind of reproduce these. So if I've got total utility and I don't have jumps of quantity of 1, so this might be something like, you know, if I'm buying these, I bought them at Sam's Club, they're like packs of 36. I can't buy 1. Right? So if I can only buy something in quantities of 5, and here's the total utility I get from all I'm consuming. So when I consume nothing, 0 total utility. The first 5, I'm getting 60 total units. When I buy 10, I'm getting a total of 105, etc. What's the additional utility or the margin utility when I buy that 15th unit? Well, I have to go from a quantity of 10 to 15. So the change in the quantity is going from 10 to 15, the change in quantity is 5. What was the change in my total utility? I went from 105 to 135. So the change in total utility was 30. So the change in total utility of 30 over the change in quantity of 5, the additional utility I was getting per unit was 30 over 5 or 6. That's how I'm coming up with my margin utility. Now, what would the margin utility be of the 20th unit? Change in quantity is still 5, but now the change in my additional or my total utility, the additional utility I'm getting is only what? 25 instead of, 15 instead of 30. So now for every for every additional unit of utility I'm getting per unit I bought, it would be what? 15 over 5. I'm only getting 3 additional units of utility for every unit I bought. So what's happening as I buy more of this good, my total utility is always going up, but my marginal utility is going down, right? So what does this look similar to? Well, here, if I'm thinking about as I buy more of something, the total utility is always increasing, but that change in total utility, or the slope, that marginal utility, it's going lower and lower. That looks similar to, what do we say with the demand curve? Declining marginal benefits. The marginal benefit of consumers really is the marginal utility. We know that as you buy more of something, the marginal utility you get from the first car you buy, insanely high. The second car is going to be not quite as beneficial to your life, right? Not bringing you quite as much happiness as the first car. Otherwise, you would have bought that car first, right? So we always know that when people buy more of something, the marginal utility is going to be declining, right? Or that change in total utility, the slope of our total utility curve, it's going to be going down or getting flatter and flatter, right? So if we think about, if we were taking those total utility values, my total utility is always increasing as I buy more of this x-axis good. But if I calculate my marginal utility, that same 1 unit increase, initially, let's say I'm just doing jumps of a quantity of 1. It makes it easy because remember, my marginal utility was the change in total utility over the change in quantity. So if I do a change in the quantity of 1, what would my kind of marginal utility always be? Just the change in utility, because the change in quantity would always be 1, right? So if I then think about, okay, what is this marginal utility? I'm going to graph that, right? That change in between 1 and 2. But notice if I'm doing the same change in quantity, but I'm at higher quantity values, so the same change of 1 for quantity, what's the change in total utility that I'm getting? Much smaller. So if I graph that out, my marginal utility at these higher quantities will be much lower. Now that's true. What's happening to my slope all the way along this curve? It's getting flatter and flatter, or my marginal utility is essentially that slope of my total utility curve. It's getting flatter and flatter, or my marginal utility is getting smaller and smaller. Okay? So these marginal utilities come from the idea that yes, total utility is always increasing, but it's increasing at a decreasing rate. Okay? Now, what we'll end up doing next class, and I won't dive too much into the mathematics or really require you to give me an excellent explanation, although I could argue from the prerequisites of this class, you should be able to do this. When we actually look at marginal utility, we think about it's generally going to be bowed inward, which represents that not only is total utility increasing at a decreasing rate, our marginal utility, this slope is going kind of getting smaller and smaller, but in fact, it's doing so at a quicker. The third derivative here would actually be kind of positive, right? Where we're getting a downward sloping demand curve, but its slope is getting kind of flatter and flatter. So we would talk about like third derivatives, but we're not going to dive into that side of it. We're just thinking about when we typically graph out what we end up calling an indifference curve, which is like kind of the idea of this marginal utility. Our marginal utility is declining, but it's not always linear. Now, we don't have to worry too much about this, like I said, for the sake of what we're doing, but I think maybe the book might mention something like this, and we might kind of touch on this next class, right? But all I really want you to know is the marginal utility that is declining, representing that our total utility is going up, but at a decreasing rate, okay? All right. So we're then going to think about how do people make decisions, right? So just because we have positive marginal utility, do I want to buy that good? Well, if the marginal utility is positive, I'll buy it as long as the price is definitely 0, right? When I'm buying something, I want to weigh out, is that marginal utility or the marginal benefit greater than or equal to my marginal cost, which for a consumer is the price. So what we're actually going to do next class and kind of talk about for the next couple minutes is we don't want to just buy whatever has the highest margin utility. We want to buy whatever has the highest margin utility per dollar we're spending. Okay? So we're going to factor in these prices, right? But then also, why don't I just go out and buy a bunch of diamonds? The margin utility is high. Even if the price is high, I might not have enough income, right? So we're going to start to have to balance out. I'm going to choose which good I'm buying based off of whatever good has the highest margin utility per dollar I'm spending. But then also, can I afford these goods given my income? Okay? So here we'll think about, I want to buy whatever gives me the most bang for my buck, which we'll start talking about as margin utility per dollar. Okay? Now, we know that when we're spending optimally, that margin utility I'm getting per dollar I'm spending on both goods should be the same. So we can think about if this wasn't the case, like why can't that be possible? Well, if the margin utility per dollar I'm spending on good X was higher than good Y, what should I do? Buy more of? Well, if I'm getting more units of happiness per dollar I'm spending, do I want to buy more or less of that good? More. So I want to buy more of good X. But as I buy more of good X, what will happen to the margin utility I get from the last unit of good X? It's going down. So as I buy more of X, the margin utility per dollar will go down until these are equal again. If I ever bought more than that, now the margin utility per dollar of good Y would be higher. So what should I buy more of? Good Y. As I buy more of good Y, the margin utility is going to go down. So the margin utility per dollar of good Y would go down until they're equal again, right? So we know that when I'm making these optimal spending habits, I'm always going to buy more of the good, whichever has a higher margin utility per dollar until they're exactly equal. Okay? So at that optimal consumption point, we know that the margin utility per dollar I'm spending on both goods should be the same, right? So we get this kind of weird paradox of value, and I'll kind of mention this. Maybe I'll, for the sake of time, kind of start next class with this. But we get this weird paradox of value thinking about total versus marginal utility. We'll then kind of work through a more simplistic way of thinking about how do I make this optimal production decision based off marginal utility per dollar. We'll then kind of move to these models. We've got, where is it at? Income and substitution effects. What I would advise before Thursday's class, maybe revisit that part of Top Hat, just coming into class, not saying have a perfect understanding of what's going on with income substitution effects, but having some of the language and starting to think about these models, like having a reference point prior to class for what we're going to be talking about might be helpful, because this gets complicated. It's very tricky. And so starting out, coming in with like a set of terms and things that where you're like prepping your brain to hear it might make our discussion a lot more valuable. Okay? So I would try to review that kind of before we start class on Thursday, because this stuff is definitely going to be tricky. Okay? Look for an announcement on Canvas. I am not 100% sure if I will, my schedule, I'm waiting on a few things. My office hours might look very different tomorrow. So look for an announcement on Canvas about what that's going to look like. I might be able to be in person, but it might be slightly different than my usual office hours. It might have to be virtual. I'll have more information later today, and I'll get an announcement posted as soon as I know. Okay? Other than that, if you have any questions, feel free to ask me after class, and I will see you guys on Thursday. Yep.